Gelber. I will have the pleasure to host today's event. And we have many participants from the Philippines, but as well people joining us from Singapore, Malaysia, and the US. We'll give it another 1 or 2 minutes before we start as people are coming in. And we have a great sign up. So we're looking forward to an excellent and very informative afternoon session. Yeah, as a German, I'm keen to usually start on time. So let's get going. We have a very good number of people already participating this afternoon. Our theme is IAQ and the workplace, ventilation and monitoring guidelines for a COVID-19 safe workplace. That's a very, very important, very critical topic. That is as well, I guess, the main reason why so many of you have signed up and are eagerly awaiting today's event, to get insight, information, how we can minimize the risk in our workplaces. And we thought we'd start off with a poll question just to get everybody going and participate. We have an intro poll here just to gauge where we all are. And the question is, what measures does your company have to ensure good IAQ in the workplace? It's a multiple choice. You can answer and click as many of those that are relevant. Do you do continuous IAQ monitoring? Do you do regular cleaning and checking of the HVAC or filters? Do you do regular cleaning and sanitation of the surfaces? Do you use safer building materials and equipment? Are you maintaining adequate ventilation to keep the CO2 levels low? Are you using plants and other natural methods? Or do you use advanced HVAC filtration solutions? Or if you're not sure, that's an option you can answer as well. So yeah, we have about 30% of all those people that are present already answered. Let me target 60+%, and then I will end the poll. And then we will see what is the favorite thing we are doing at this point in time to keep our workplaces safe. Yeah, we're just hitting about 60. I think I can wait till we have achieved 70. Please click and submit your answers, and then we will get interesting results coming back from our poll. Yes, we're hitting 70 now. Done. Great. Excellent. Let me share the results with all of you and see what we have. You should be able to see it on the screen now. And the number one measure, not surprising really, is the regular cleaning and sanitation of surfaces. And then followed shortly behind that with 64% of you maintaining adequate ventilation. Very important, get the fresh air in. And then thirdly, in our list of top priorities is the regular checking and cleaning of HVAC and filters. Interestingly, the continuous IAQ monitoring is done by 44%. That's quite a high number as well. And not sure, very few. So that seems to indicate most of you are actually proactively managing the workplace with regards to reducing the IAQ risks. But let me not further dwell on this. We have amazing speakers today. We have Dr. Teresita S. Cucueco, who is the Assistant Secretary of the Department of Labor and Employment, and Dr. John Q. Wong, who is the President and co-founder of Epimetrics Philippines. And then we will as well get a reaction from Elmar La Pena. So without further ado, I would like to ask Assistant Secretary Dr. Tess Cucueco to start her presentation and share with us her amazing knowledge on the subject.
Good afternoon, and so that we can start right away, can I share my screen? But you do have a copy of my slides. So will you be sharing my presentation, or can I share?
You can share. You can share.
Okay, thank you. Okay. This is a department order issued by the DOLE, the Department of Labor and Employment, and this is now a standard, as we all know, like safety and health standards, and this is really providing the workplace guides on ventilation, and our focus here is how to well ventilate air spaces, especially if we talk of reducing the risk of transmission of COVID-19. So
would it be possible to switch into presentation mode? Then it's
yes,
okay, great. Thank you so much.
I kind of missed that. Okay, so the purpose of the department order is that, and its coverage will be for all commercial and industrial establishments, all projects and sites where work is being done. It shall not cover healthcare facilities because we know that healthcare facilities may require even more stringent ventilation procedures or guidelines. If you look at our whole guidelines, it is really, we do define certain terms that were used, but to shorten it and just to highlight what is important, when we talk of ventilation, there are two areas that we look at, whether it is air conditioned or not. And I will tackle first non-air conditioned spaces, because here you can open windows and doors. And if we talk of ventilation and the free flow of air into these spaces, we understand that by knowing this, this air movement, the air exchange that can happen because these are now naturally ventilated, we are also giving in our recommendations. And this is where we say that the best, if you do have windows and doors and other openings, we maximize this natural ventilation. Fresh air is brought in, and then if there will be any contaminated air inside that space, it is brought out. But we have to ensure that the natural air brought in is free of contaminants. If you are in basements or in areas where your next door, where the next door building or would have certain chemicals, and it will not be, of course, natural or fresh air. These are things that should be considered, because then all of these vapors, contaminants can come in, and that would also be, that is not what we want, because there will be exposure to other hazards as well, the chemical hazards. Now, if natural ventilation is not feasible or inadequate, we do look into the use of fans and air conditioning system for that supply of air. But then we also have to understand that once this is going to be done, there should be an extraction of contaminated air as well. If this is going to happen, then we would like to achieve a dilution ventilation, the use of exhaust fans, to achieve an air change of 6 to 12 air changes per hour. In these guidelines, we have the formula, and we are telling our safety officers, those who are knowledgeable, that they can compute this if they want to use these parameters, so that that air change, think of your air now inside the room, and what you want is that all that air is brought out, and you can have, and it is best that you would have these 6 to 12 air changes, because that means whatever is inside the room will also be replaced. It will be brought out, there will be a replacement of fresh air, and you're talking of cycles of 6 to 12 in an hour, so that if there is any contaminant inside, it will be brought out. The installed exhaust fan should be kept continuously open as much as possible. If the use of ventilating fans is unavoidable, we have to increase outdoor air changes by opening windows and other openings. Airflow direction should be considered in the layout of workstations to avoid person-to-person spread. If you are using fans, please, we always have to bear in mind with COVID, there will be asymptomatics. And what we would not like to happen is that secretions from a possible asymptomatic may be transferred on because of air movement from one person to the other, and that would be brought by the airflow from the fans. So that layout, that design of the work layout is very important. And of course, it is very, very important that these there should be the proper cleaning of windows and other openings and the ventilating fans as necessary. Okay. Now, if we look at air-conditioned spaces, the earlier one was on non-air-conditioned. Here on air-conditioned, and this is where indoor air quality will really matter, because you would like to have a very good indoor air quality, and these are supply of air brought in through mechanical means, and that there should also be the removal of air through the air handling unit. And that is why it is very, very important that the HVAC system and the outdoor air supply should conform to the recommended breathing zone ventilation rates for the purpose of general air dilution and comfort control. All of these, the tables for this is found as an annex to this department order, so you can refer to that. If you have an air handling unit, the ventilation system should be on 30 minutes before and after, because what we want is that before people come in, there is that, the air circulation that has happened and bringing out of any stale air that was present earlier with no people yet, no occupants yet, or just a few of them when they start this, and to be brought out. And after work, where there would already be a number of occupants that have entered the room, if there is any contamination, then it is also brought out so that it will not stay inside the area, and you are ensuring that the air inside will be, in terms of the contaminants present, it would be of very low risk or very low number, possibly none at all. So if you have local air conditioning only, dilution ventilation may be done through the use of exhaust fans and filters MERV 13 or higher. So if it's not a full air handling unit, then if it is just local air condition, the supply of air through the air conditioning unit will have to be removed through the exhaust fans. And that is why we are saying that these are very important details that you should consider. And because usually filters in air conditioning units may not handle the best filter that may be present, we are looking at a MERV 13 filter. If it can be fit into an air conditioning unit, that would be good. If not, then there might be the need for having other purifiers that will have to be installed. And we should also ensure that enough exhaust fans relative to the room volume are present for the required breathing zone ventilation rates. Again, this is already attached to the annex. Okay, if ventilation is greatly recirculated or access to outside air is not feasible, we really try to limit recirculated air, especially because we know that if there is any contamination and there is no filter that is going to purify whatever contamination, we have to, we have to ensure that because of the recirculation, there should be a HEPA filter that is present in the air handling unit, because that is the only way we can be able to purify or remove the contaminants from the recirculated air if it is present. We also have to understand that the units which would have these HEPA filters should be adequate for the size of the room it is installed in, and there should be proper maintenance of these HEPA filters if you are using additional purifiers. For local air conditioning units, again, we have to look at the layout and making sure that the louvers are in an upward position. Again, we do not like those drafts, those airflows from one person to another. We also would like that there should be the opening of windows, doors, and other openings to supplement the mechanical ventilation in achieving dilution, because opening of these windows and doors will bring in fresh natural air, and it will also add into the dilution of the contaminants if present inside an indoor airspace. The cleaning and maintenance, as mentioned earlier, even for non-air conditioned, is very, very important. We should, this is now air conditioning, so we should ensure that there's no mold or stagnant water that will be circulated in the atmosphere. And for those who will be maintaining and cleaning these equipment, the appropriate PPE should be worn. In many workplaces like restaurants and even in hotels, there will be local exhaust ventilation, or in the manufacturing industry, or in where work will have to have the use of chemicals, or here in cooking. Local exhaust ventilation is also another means of removal of all this stagnant air or indoor air that would produce smoke or would have contamination. And this local exhaust system shall have the basic components of the hood, the ductwork, the air cleaning device, the fans or blowers, and the exhaust stack. So all of these LEVs should be equipped with the proper air cleaning device before it is brought out, so that the air that passes through it will be purified before it is brought out. And we are looking at the continuous operation of this local exhaust ventilation system when workers are present, because it will also allow additional air change. However, if the running, it is also important that these hoods are properly secured and not used to avoid disruption of operation. Oh, sorry. Okay, for restroom and water closets, as we talk of office spaces inside any establishment, the rules here is that all exhaust fans and the restroom facilities are functional and operating at full capacity when building is when there are occupants in a building or in an office. We want that it is always on the whole time, because when any occupant will enter the restroom, then it will there would be that we are reducing the risk of whatever was present, and when somebody comes in, that contaminant is already removed. Now, when toilets or water closets are used, of course it's advisable to close the toilet bowl seat lid before flushing, because we are minimizing the release of droplets. And in these restrooms and water closets, we advise not to use hand blowers or jet dryers, as it contributes to dispersion of potentially contaminated air inside the restrooms. Now, for the public transport, we will always use what has been issued by the Department of Transport. Again, the guidelines are still the same. We, of course, advocate the use of natural ventilation. For vehicles, we are telling those operating these vehicles to avoid recirculated air option, and that we can still provide better ventilation if windows are open by at least 3 inches. But if there is no possibility of opening these windows, considering the buses or the rails, then we do not force that issue. But what we're saying is that opening doors for passenger exit and entry should have at least a minimum of 15 seconds, so that with that exit or entry of 15 seconds, there's that supply of air coming in. Remember, our goal in ventilation is that there is a natural air that is coming in and always an exit of contaminated air. For all of this, even in vehicles, that there are proper maintenance of the air conditioning units and filters if they are being used. And for vehicles, as well as in all the offices, it's not enough that we are just doing the ventilation standards, all minimum public health standards. We are not doing away, even if you have already good ventilation through the filters, through all of the strategies mentioned here. We are still, this is together with the use of the compliant with the minimum public health standards, the use of face masks, face shields, the frequent disinfection, physical distancing, all of this again, and again should also be complied with. So these are for the those in vehicles, in transport, face mask, face shield, frequent disinfection after a route, 1 seat apart, but now the transport department allows sitting beside each other as long as plastic barriers are present. COVID-19 information materials are also should be displayed. No talking, no eating, because that would mean masks are off, and that is not what we want. And we would those secretions will be out, which may be a risk for infection. And of course, that symptomatic passengers are not allowed to board. These are two, on assessing the ventilation, we have put two strategies here. The question that was asked us as we were doing this was, how can we assure small business if they do not have all that equipment to determine or assess their ventilation? So you would see later a self-assessment checklist that is part of this department order. And there are simple questions, but answering it through a yes or no will tell you what necessary actions to be done so that you will have better air quality. And the other measures that we are looking at subjectively to see if there are, the possible non-good ventilation practices going on would be the lingering smells, stuffiness in the room, the humidity, smokiness. So all this we do not like. It's part of the qualitative assessment, and you will see the checklist later. Now for the quantitative, we are looking at now air movement, the airflow, carbon dioxide as a surrogate indicator, meaning to say you would have to have this equipment so that you can measure the carbon dioxide levels to see if it is increasing, meaning to say it is not going out. There is a number of people in the room where you are building up the carbon dioxide, and if it is not going out, then even the secretions or everything else that is happening is also not going out, and that is not talking a good indoor air quality. So indoor plants and gardens are also helpful to bring down, of course, carbon dioxide levels to lower rates. And the air changes, as I mentioned earlier, if you do have the anemometers, you can use this so that you can determine the air change per hour. And all of these, if you are using this equipment, they should be done by a trained safety officer, or you can ask an outsourced service provider to do this. So for monitoring, it will be inside your companies, the Safety and Health Committee. We have the checklist. Now for the offices, then it would be the DOLE regional office to do this. Technical assistance may be provided by any of the government agencies that would be looking after the different sectors here. So this is already part of the guidelines, our department order, and we have our partners in government to assist. So this is the checklist that I have discussed. So it's very simple. If it's non-air conditioned, you can use this. So are your windows kept open? Is there no lingering smell? Are the nearby spaces openable and free from toxic gases? If you put yes to all, then you have an assurance that the ventilation in that space is good, and you may not need any further actions to be done. However, if there is a no, then maybe we look further and see what would be the next best recommendation to follow. Now here, this is on a quantitative checklist now, and here this is for air condition, and now we're looking at more technical guidelines here, where we now look into the filters if they're MERV 13. Again, there are still the subjective symptoms, because these are really very important as you also look into air-conditioned spaces. If there would be HEPA filters, if you're using the air purifiers, the CO2 levels, if you do have, and you're measuring this at 1,000 lower than 1,000 parts per million. And we also have to look into variations in temperature in these indoor spaces. This is the minimum ventilation rates in breathing zones. This is already part of the National Green Building Code. So this is highly technical. I leave this to the engineers to look into this and to comply with this minimum ventilation rates. These are the air changes per hour. And I think that is the last slide. So thank you. This is now being, this should be complied with by all establishments here. And we now have a safety seal certificate. And this is for public, this is really more to assure the public that if they do have that safety seal sticker or display certificate that is displayed outside, it means to say that company or that workplace is complying with all minimum public health standards as well as the ventilation standards. So having said that, again, thank you for inviting the DOLE, and we're here for any questions later. Thank you.
I nearly forgot to unmute myself. Thanks, Dr. Tess, for the very insightful presentation. And I'm sure there'll be a couple of questions, but we will leave them till after our subsequent speaker, Dr. John. He has got a lot of great insights into the subject as well. And I'll hand over to you, Dr. John. Looking forward to your presentation.
Thank you, Matthias. Let me share my slides. Can you see my slides?
Yeah, perfect. Presentation mode, excellent. Thank you.
Okay, thank you. Okay, so let me talk about how we can. So as the economy opens, more and more workers will return to work, and more people will stay indoors. So how do we do these activities safely again? So key messages are: there's increasing evidence for airborne or aerosol transmission of SARS-CoV-2. But fortunately, we have guidelines and tools that we can use to both assess and then improve indoor ventilation. And then we should have a paradigm shift from risk avoidance, which we've been doing for the past year, to risk assessment and management. So there's increasing evidence of airborne transmission. So initially, we thought that SARS-CoV-2 was just transmitted by droplets. Let me first differentiate between what is a droplet and what is an aerosol. There's actually no hard line differentiating the two. It's more of a spectrum. So droplets are usually larger and heavier, so they drop after a few feet, a meter or two. Aerosols, on the other hand, are small. They're light. They carried by water vapor particles. They carry it farther and stay in the air longer. So you can see this in a person that sneezes. The heavier droplets travel just a few feet, and then drop to the air. Just a few are spread. But aerosols, being lighter, can be carried as far as 26 feet. So there's already multiple sources of evidence that SARS-CoV-2 is transmitted also by aerosol transmission. So, for example, so we've seen super spreader events that account for actually most of the SARS-CoV-2 transmission. So these occur in restaurants, choir concerts, and buses. Most of these are indoors. They've also seen in quarantine hotels that even when people are in adjacent rooms with a divider, there can still be transmission. Third, they've seen that even before people become symptomatic, they can already transmit infection through breathing and speaking. They don't have to be coughing. Transmission is also higher indoors than outdoors, and that indoor ventilation does reduce transmission. And then even in hospitals with strict compliance to infection and prevention control measures, they've also seen infections. They've also been able to collect live viruses in air in rooms and cars that were formerly occupied by COVID-19 patients. They've also found the virus inside the air filters and building ducts of hospitals. And then when they did experiments of cage animals beside each other, but separated, they're only connected by an air duct. Transmission can occur. And then they've also seen this phenomenon they call overdispersion, that a minority of primary cases account for a majority of secondary infections. So this is a good mnemonic to use with regards to aerosol transmission. So what are the risks of aerosol transmission? So they happen indoors, the indoor venues. They happen when ventilation is not good, not being exchanged, diluted, or filtered. And they happen when people are talking or singing. So the 3 V's, venue, ventilation, and vocalization. So examples are restaurants, bars, clubs, choir practices. All of these have been settings for super spreader events. In Japan, Japan actually did not have a prolonged or strict lockdown, like in most countries. Aside from the Diamond Cruise super spreader event, Japan has been able to control their transmission very well, and it's because they follow these 3 C's. They tell people to avoid closed spaces, crowded places, and close conversations. So this is a diagram of an outbreak that happened in a restaurant in China. So it's enclosed, it's air conditioned. So 3 tables. The air condition is here, and in this table, this is the infected person. So the air current is blowing from here. So later on, they found that 3 of these 4 people were infected. And that's to be expected because the wind is the air is blowing in this direction. But they also found strangely that these two people were also infected on the opposite side. And their hypothesis is that the air blew in this direction, bumped off the wall in this direction, and came back and infected these people. So proof of aerosol transmission, traveling more than a meter. So just another diagram of the same situation. Infected person, these people were infected from the air blowing here, but these people were also infected. This is a case again in China. This is inside a bus. So this is an infected person. Normally they say that in buses or in planes, infections are usually 3 or 4 seats in front and behind. So these are the infected persons. So it follows 3 or 4 seats in front and behind. But they also saw that there were also infections that were farther away. So again, no sign of aerosol transmission. And this case in Seattle, Washington, choir practice in an enclosed church. This is an infected person, and they infected 32 out of, I think, 50 people. So that being the case, how do we protect ourselves? How do we protect our customers and our workers? There actually are already multiple guidelines so that we can use. As Cucueco has presented the DOLE guidelines. But there are also guidelines from WHO and the Lancet. These are all hyperlinked. You can look at them later. There are also some tools that we can use. Maybe we can look at a couple of them. So this is the tool from MIT. Here you can customize it to your own situation. For example, if it's a restaurant, no, people are not wearing masks because they're eating, no, and they're also speaking. No. And then this is the Delta variant. So this calculator shows you, how many people you can have in that room, and still be safe, So for example, normally people stay about half an hour in the restaurant, so you can have 25 people max, for half an hour. If we have the Delta variant, and then you can also change this, depending on how large or how small your restaurant is, Okay. So I'll leave you to play around with this. There's also another calculator by Harvard. Whereas the MIT calculator computes the number of people you can have in a room safely, the Harvard calculator gives you your risk of infection given certain conditions. They also include carbon dioxide measurements. So these are things that you can do, and they have been summarized very well by Cucueco. In a room without air conditioning, open windows and doors, preferably opposite each other. Install window fans, to exhaust the air out. And then you can also add HEPA filters, but you have to make sure their HEPA filters are sized, according to the size of the room. And then they have to be strategically placed also. If you have a room with air conditioning, you run the air conditioning earlier than people arrive, and run it for about 30 minutes also after they leave. And then if the air conditioning allows, allow more outdoor air, to come in. So open the exhaust a little, so that you're always constantly introducing outdoor air. You can also upgrade your filters, to use MERV 13. These are high performance filters. And then you can also add air purifiers. This is a famous case. So another thing, so those are interventions to improve the quality of your indoor air. But you should also be monitoring the quality of your indoor air. And one good proxy for contaminated air is measuring carbon dioxide, because in a room full of people, they all exhale carbon dioxide, and the higher the concentration of carbon dioxide, the more likely that you're not filtering, diluting, or exchanging your air properly. So there's this famous case of a gym, because one of the members was an environmental engineer. She was able to help the owner improve the gym. They opened windows, doors, and they had the carbon dioxide monitor. So whenever this monitor exceeds 1,000, they would open windows or doors. And then there was a time where one of the personal trainers became infected with COVID-19. And when they tested the members, none of the members turned out positive. And they think it was because that they had very good ventilation. So this is a case study of how monitoring carbon dioxide levels helps prevent transmission. So we have several parameters. We've been doing masking, social distancing. Now there's another variable, ventilation. So one rule of thumb you can use is the 2 out of 3 rule. So when do you need to mask? When do you need to improve ventilation? So if you're outdoors jogging, you have good ventilation, you're distance from other people, you don't need to mask. Indoor in a restaurant, you cannot mask, of course. They're eating. You can spread your tables apart, but you need to improve ventilation. in order to comply with the 2 out of 3 rule. How about in a factory production line? You can mask, because it's an assembly line. Sometimes social distancing may not be possible. So you also need to improve ventilation. Okay, so we have to move from a paradigm of risk avoidance, where you have to close everything, and work from home. For manufacturing entities, you cannot work from home, but so these people are constantly at risk. So we have to move towards a paradigm of risk assessment and management. Instead of asking the question, which businesses are unsafe, and then close them, we move to our paradigm of how do we do this activity safely. And that's what the safety seal is all about. We could open more businesses, be more surgical and precise about identifying risks. The disadvantage is that we have to self-regulate, or regulate properly. So this is the hierarchy of controls. This is used in occupational health and safety. So we try to eliminate the risk by working from home. Well, we cannot substitute but we can apply engineering controls by opening windows, exhaust fans, HEPA filters, MER13 filters, introducing outdoor air, and measuring carbon dioxide and air exchange. We can apply administrative controls by limiting time indoors and limiting occupancy. But of course, this affects the business. Or we can require PPE, which is masking. So these are more effective, and these are least effective. So we shouldn't always be relying on masking. The key intervention here is engineering controls. I think that's my last slide. Yeah. Okay. Thank you.
All right. Excellent. Thank you, Dr. John. We have a quick reaction from Elmar Laperna, the Testec Group President, and then we will go to the questions. Loads of questions coming up. I'm looking forward to an exciting Q&A session. So quick comments from Elmar.
Yes, just very quickly, thank you very much, ASEC Tess. We know your schedule is very busy, and we're very honored to have you here today to address all of us and to answer all these questions. Thank you very much, ma'am. And Dr. John Wong, also, thank you very much. The key thing that Dr. John Wong is talking about today is aerosolized or airborne transmission. And this is something that early on the WHO and DOH did not recognize. So airborne transmission of the virus has really changed the way we need to fight and to protect ourselves. And that is why we have the new ventilation guidelines, which were published this year by the DOLE. And many companies until today are still learning about this and finding out how they can mitigate whatever situation they have. And many of our air conditioning systems, especially the recirculating air conditioning types, unfortunately do not provide any fresh air ventilation. So everybody has to start rethinking of how to do things. And as ASEC said, the best, and I quote, the best air is the free-flowing, natural, and fresh air. So with that, thank you very much. Matthias, I'll throw it back to you so we can discuss more of the Q&A.
Great. Thank you, Elmar. There's a lot of questions that have come in, both in terms of people submitted it in advance and questions that have come in now. I'll give preference to questions that have come in now because sometimes people don't actually turn up who ask questions in advance. So anybody, please share your questions again in the Q&A or in the chat section. You will as well get the recording of this event and the presentation slides as they are permitted to be shared by the speakers. We have here the first question that came in on the chat box is a question for clarification, whether the operating install fans from Annex 3, is it ventilation fans or exhaust fans unit? So very specific question.
if they go through, yeah, I saw this already. And if they go through the footnotes in the formula, they will see where they will use the ventilating fans, and I think it's the velocity, and then the exhaust fans, the number, that's the part where the number of operating fans, that would refer to the exhaust fans. So just take a look at the footnote po.
Yeah, there were as well a couple of questions on air changes per hour. I think that's covered in the footnotes as well. Here is an interesting question as well. If the area already passed the carbon dioxide level of below 1,000 parts per million, do we still need to measure the air exchange per hour of that particular area, or is that obsolete?
No, I would like to think that you can complement both, because the CO2 will really work when you have so many people inside. I mean, if your place or your venue or your workstation would be like a restaurant or a convention area, you really have to ensure that the CO2 levels there are really kept to below the 1,000 parts per million. But the air changes will also provide you the necessary means or an indicator that you are also doing the good air change that it should be happening in, and these are really big areas. But if you do have a small, like a small restaurant, CO2 would be fine, as long as you know where and that it is measured properly. You do not measure beside the window, because definitely your CO2 level will be very good, because there's no one there. There's no CO2 being brought out. It should be where there would be a density of people. So we do have to guard you against the proper use and measurement of all of these.
Yeah. When I first came across this was when I was working for the ADB a couple of years ago, when they had their CO2 monitors installed, and the air handling units brought in the fresh air as soon as it hit 800 parts per million. So even automation is a great possibility in this context. There's a very interesting question actually saying, if the air purifiers have UVGI in the air-conditioned room, and they don't meet the 1,000 parts per million, can they just go with the OSH standard of 500 parts per million? Is that okay if they use other ways of eliminating the virus?
I think I would ask Engineer La Peña to weigh in here.
Yeah, okay. You know, the UVGI does address the virus, provided you can have enough circulation of the air going through your UVGI. However, this doesn't happen all the time. When people enter and you have a big room and a small UVGI unit, the time for the air to circulate through the UVGI is rather long. So during that time, people inside the room will be exposed to whatever particles are inside the room. So again, CO2 is a different indicator. It's a surrogate indicator of how good your ventilation is. It also means that your fresh air comes in fast enough to prevent the buildup and accumulation of virus particles that can affect the occupants. You need 1,000 virus particles to get infected. A person talking emits 200 virus particles per minute. So you can do the math. It can happen very quickly. And if somebody sneezes or coughs, that's 200 million in one shot that gets into the air. So if your ventilation system is good, then you have a much better chance.
Yeah, I totally agree with it, Elmar. I actually have a similar problem here in my office where I am now. I am struggling to keep below 1,000 parts per million unless I open the doors and windows. But if I open the doors, my kids will come in and jump all over my camera and get you all excited. So it is quite tricky, even in case if somebody sleeps in this room, because it's an inside room, there is no real window. So it's quite tricky. I personally try and keep the CO2 as close as possible to 1,000. And I have installed bipolar ionization here as well, similar to UVGI. as a way to eliminate virus risk. So there are a range of different things you could do, but the top priority should definitely be below 1000 ppm. I remember going into a platinum certified office in Metro Manila, but there was a partitioned area inside a meeting room. And even though this was platinum certified and the air handling unit were complying with green building standards, the CO2 level was nearly 3000 in that small room. So we really need to measure, I think, the carbon dioxide levels. Otherwise, we don't know what's going on. So I would strongly recommend that. Let's go to the next question. Exhaust fans, we covered that already. Let me go to the Q&A part here where we have a couple of questions. The safety seal, if there are several tenants in a building, will each tenant be required to secure a separate one?
Okay, let me, this is another seminar altogether, but in short, the safety seal is a certificate, and there are many of us regulatory agencies that are providing this. So for malls, that would be the LGUs. Now the tenants, if there are barbershops, groceries, pharmacies, you're going to have the DTI looking into this. If it's going to be for food outside, if it's a hotel, there's a hotel inside there, that's going to be the OT. But what we heard from the LGU is that once they certify a mall, they are also looking at all the tenants inside. So I'm not sure if but that is what they say. Once they look at a mall and say the safety seal can be given to the mall, they have also looked at all the tenants. That might be different in different LGUs. So because we have to understand that there are there will be different LGUs, the mechanics will be different. But as a mall itself, that will be the LGU. But for the inside, those tenants inside, then if it's not going to be covered by the LGU, then there are specific government agencies to look into this and to certify. Like I said, if it's a grocery, that's DTI. If it's a pharmacy, it's also the DTI. If utilities, that's the DOLE. And these are utilities like you pay the Globe for Smart, then that would be DOLE. I know it's, but we do have sectoral assignments here as we also issue the safety seal.
Thank you so much. Next question here is from Dexter. I'll pass that on to Dr. John. In case of a contained area where MERV 13 are not be applicable for the existing old air conditioning system, will it be possible to use air purifiers alone, Dr. John?
Well, there's several things you can use. No? Yes, you can use air purifiers, but there are all. But if there are also windows and doors, no, you can try opening them, not to introduce fresh air. No, so in COVID control, they talk about the Swiss cheese model. No, meaning not all interventions are 100% effective. No? So try to use multiple interventions, no? So that you can increase the effectiveness, no, of your attempts to reduce transmission.
It just reminds me of a trip I took from Metro Manila to Laguna with Jackliner before the pandemic. And I had my uHoo indoor air quality monitoring device, and the CO2 levels in the bus were more than 6,000. Now, Dr. Tess, you mentioned earlier on about the buses and the ventilation. My wife might not allow it for me, but I would love to go back into the bus again and actually monitor the CO2 levels there. Are there any studies about public transport and CO2 levels in there that have been conducted?
I know that the DOTR is doing this because of that issue with those plastic barriers, if it does work or not. Let's just wait for this, and we will share it with you once they have also completed it. But I know they were looking into this already. So, but I don't have any initial input to give here.
Great, yeah. I'm not worried about the jeepneys. They are very well ventilated, but the buses is a little bit tricky, yeah. I love going by jeepneys as well, by the way, but my wife doesn't allow me anymore now. I live in San Pablo, Laguna, since the pandemic. So I had to buy a car. Before I was always using public transport. Next question is from Walter. Has DOLE considered the bipolar ionization technology as another layer of protection against COVID-19 aside from HEPA filters?
Okay, when you look at DOLE guidelines, we're just looking at the minimum standards. If our minimum is really the MERV 13, the HEPA, if this is higher, but I will leave that to the engineers. Maybe engineer Elmer can weigh in here. But if this is a more stringent, then that's fine. Because really, what we're talking of are just the minimum. If it is definitely higher, you just have to prove it. You know, if inspection will be done and say it is of, you know, this is even better than your MERV 13, then that's okay. We will not argue.
If I may add, yeah, go ahead, Dr. John.
Well, from the EPA website, they say that this is a very new technology. No, there haven't been a lot of studies on this. No, so they're still waiting for studies on this technology and its ability to reduce SARS-CoV-2 transmission. No? So I wouldn't say just depend on this. No, try to use the other more older but more dependable and proven technologies.
Thank you for that, Dr. John, because if our inspectors will come back to us, at least we have something to say.
Yes.
It's
If I may, yeah, if I may also add, the other question is about time. Remember, we're all talking about exposure. So the longer we are without our face masks, the more we can absorb the virus and get infected. So how long does it take for bipolar ionization technology to become effective, as opposed to the amount of viruses that may be released into the air? And this is the question that we have to answer, because if the loading is very high, it may take a long, long time for any technology to be effective.
Okay.
Yeah, I'm a big fan of it. I've used it here in my home, but you're right. We need as many studies as possible to look at all the different variables. If somebody is next to you that is infected and singing while you don't wear a mask, then I don't think any technology can actually prevent it unless you have the mask that you're wearing. But I think coming back to Dr. John's statement, we need to find the right balance between prevention, the kind of getting rid of the root cause, and then as well the protective equipment. What could be a vision for us to find the most cost-effective way forward? I mean, currently a lot of businesses, we had as well the question in advance of the event, what should factories do was one of the questions that have been submitted. I think, Elmer, you have done quite some work with factories. What is your recommendation? Because I have seen in Germany and in Malaysia, factories have been the main super spreader location. You mentioned, Dr. John, meat factories. That was the big problem in Germany as well, with gigantic outbreaks in meat factories. What should factories do currently?
Well, for factories and workplaces, I think the first thing that should be done is to measure. You have to measure and know what your indoor air quality is. And only when you know that, then you can start taking action. If the problem is, let's say, carbon dioxide level, then you have to look at ventilation, you have to look at occupancy, the loading. Maybe you have too many people and the ventilation system or the ventilation rate is not enough. It may be 6 air changes per hour, but if you have more people, then that can eliminate, then it won't be effective. So you have to have a measurement system. And I think that's the best approach, because if you have a measurement system that works continuously, any changes that happen, whether you add more people, you close a window, a ventilator breaks down, or air conditioning goes from high speed to low speed, and the conditions change, you would immediately know the effect, and you could also take actions to fix it right away.
Dr. John, your recommendations for factories?
I agree with Elmer. No, we have to put in multiple protections. No, so as I showed in my slide, no, they can wear masks, no, but they may not be able to socially distance. No, so you have to improve ventilation, and maybe also do some administrative controls. No, like reducing the time they spend together. No, if you can automate some processes. No, or work out some ways where you can have fewer people now inside the room.
All right, excellent. Before we close today, we are already coming close at 4 o'clock, or looking at my watch, it's actually 4 o'clock. Let me launch our exit poll, our poll number 2, where you can actually let us know what kind of follow-up you would like. This is very quick. It's again multiple choice. Do you want to be connected to the DOLE office, Dr. John, Elmer, uHoo, or even to myself, the Green Man?
Matthias, while they're doing the poll, can I just also mention the best, for workplaces, the DOLE has issued the BTI DOLE guidelines, which looks at all possible interventions for the minimum public health standards, including ventilation, including physical distancing, the use of the face mask, the face shield. That should all really be put together if you want a good strategy in bringing down the risk. One cannot go beyond another. It has to be protocols that will complement and supplement each other. Then we can really talk of looking at conditions at work, actions of our workers that would move from being unsafe to safe, and really drive down the risk.
Excellent. That's a great word of wisdom for finishing our event. Let me just finalize the poll, and then we will have that data to follow up with you. And no surprise, you are the most popular, Dr. Tess. Most people want to follow up directly with you, and this is great. I think it might be worthwhile mentioning as well that uHoo has actually got a built-in virus index, which calculates based on carbon dioxide, humidity, and other factors, the virus risk. So that's an extra bonus if you ask Elmer to help you install one. And I have been using it here at my home and in the places that I've traveled to. And as I mentioned, one of the most scariest scenarios was the bus scenario, where I had 6,000 ppm CO2 levels, but that was before the guidelines came out. That was before COVID, where it didn't really worry us. I learned a lot today. Thanks everyone for contributing. Dr. Tess, thank you so much for contributing your valuable time. Dr. John and Elmer, this was an amazing event. We could have continued for another half an hour, I think, with loads of additional questions. Thanks everybody for spending this afternoon with us. And let's all be safe. Let's do the best. Let's keep our CO2 down and bring the fresh air in for a safe environment. Thank you so much. Thank you, uHoo, and goodbye, everybody. And uHoo will be in touch with sharing the documents with you.
Thank you.
Thank
Thank
you.
you.
Thank you. Thank you.